Okay, so things that you should be bringing to this video, because this is a part 2 of the series for our G&M code. The thing you should be bringing to this video is your planned out layout of your initials for your block. It should have all of the letters labeled, right? This should already be done. You should also already have done exactly what all of your points are. So these correspond to, like, point A is 0.3125, 0.3125. That corresponds to my point A here, 0.3125, 0.3125, okay? And so the 4 sheets that you're actually going to need for this video, 2 of them required your work. The other 2 shouldn't really have any work on it. It should be our reference codes, and we're going to be looking at this a little bit, and then this planning tool. And I've made a couple of changes so here. It's not too crazy. The spec sheet says 9 inches per minute, that's what IPM means, but we also want to have 18 inches per minute. So we're going to say 9 inches per minute for when we actually plunge into the part, and then 18 inches per minute when we're moving through the part, because 9 inches per minute is a little bit slow. Okay, so when we're going through this, we can read this. These lines right here, the block, is just what line of code we're on. So this is line 0, this is line 1, line 2, line 3, line 4, line 5, line 6, and so on, okay? And you could have, like, I mean, you'll make programs in here that are 25,000 lines long. You don't have to do that right now. You're not going to be doing that by hand. That'll be generated by the computer, but we want you to be able to read what's happening in those codes. Let's say if there's an error. The best way to do that is actually just to write some simple code. So line 1, it says G90, G20 is our G codes. So I'm going to look back at my reference sheet, and I'm looking for G90. So I'm going to look at my G, and these are what we call preparatory codes. And I see G20 is in inch mode. So we're going to be talking about in inches, which makes sense because our layouts are in inches. And then we are talking about, let's see, I'm looking for G90, absolute coordinates, and we are working in absolute coordinates. So we are working inch mode, absolute coordinates, all right? And then, so that's line 1. So line 2, it says a tool change, and we're putting the tool tool 1, which is our 1/8 inch end mill. Okay, so that's matching up with what we're reading up here, 1/8 inch end mill. And our miscellaneous codes, nope, are frequently used. Let's see, where are my M codes? Tool change right here. So our MO6 code, and we say MO6 right here. It matches up with my M codes, and it's going to be tool 1. Okay, so this is tool 1, and MO6 is the tool change, and we're getting that from right here. Okay, so the first 2 lines are almost always going to be the same for your codes. This might be G91, or if you're doing counterclockwise or clockwise through a curve, which you will in a little bit, it would be G02 or G03, depending on which direction your curve was. So you're just got to get used to writing with these codes. It comes down to familiarizing yourself with the code and imagining what the machine is doing. Okay, so then we have our spindle speed. And remember, you've already calculated how to calculate your spindle speeds, and we're going to be spinning at 3,000 RPM. And so we say MO3, that's our turn spindle on, and then we're going to say turn spindle on at 3,000 RPM. Okay, so far we've turned the machine on, we've told it how we're going to read the code, we've told it what tool we're going to use, we've told it how fast that tool should be spinning. We haven't really moved it all. We've just turned the machine on and made sure that the spindle is actually spinning. So made sure that our mill is actually turning around. Okay, next up, we're going to have our first movement, and we're going to say GOO. We are above the part right now. So right now you have a block of wood that's sitting in our CNC. This is our stock. Okay, and we have a spindle, a little drill. Imagine it being a drill. We call it a spindle, and our end mill on it. Okay, and so far we're turning it on at 3,000 RPM. Okay, we have not moved this at all, and we are above the part. We're not milling anything right now, and so when we're above the part, we can move at GOO. And if we look at what our GOO is, that is rapid traverse. That means that this machine is going to go as fast as it can possibly go to whatever position you're at. And so you definitely do not want to be milling when you hit this code. You don't want to be in the part when you use this code, because you might break your spindle, you might break your part, things might shatter, and that would not be good. You don't want to move that quickly through the part. But when we're above the part, we want to move quickly, because in the end, time is money, and we do want to make sure that you are using the machine time efficiently. Okay. So we're going to say GOO, and you can see I've put rapid to above point A, and your point A might be a little different than my point A depending on what your initial was. My point A just happened to be 0.3125, 0.3125. That's this A right here. Okay, yours might be different. Maybe you started yours up here, and your point would be 0.3125, 1.6875. So it really depends on what your initial is, whatever this point would be. Mine is 0.3125, so that's what I put. So I'm still above the part. I am not milling yet. Nothing, the wood has not been cut yet. Okay, and then I'm going to move rapid again, and this is going to move to the Z axis, and that is 1/10 of an inch above the part. Okay, so I'm still not on the part. So far I've moved down really quickly. I'm about here above the part. I'm not actually milling yet. Okay. So far, we've really only had to enter one thing here that is different, that might be different on your parts. And it's this right here. It's just moving to rapid above point A. You're not actually milling yet, okay? And then we're moving rapid to 1/10 of an inch. And then our next one, you can see how the Z-axis has actually gone negative now. If we're negative in absolute programming, that means we're milling in the part. And when we go actually start plunging into the part, okay, so now if we look at our little diagram up here, now when we're plunging into the part, we're actually milling something. You've drilled a hole. Okay, this is actually drilled a hole. And when you're plunging or retracting, we want to go slowly. So we're going to set that feed rate to F9. So we've changed our code to GO1. Okay, so GO1, if we look down here, linear movement, this is just straight. This is just straight movement. And we are going slowly on straight movement. Okay. So once you hit GO1 though, you don't have to hit GO1 again until you change the type of movement that you're doing. Okay. So I'm not going to do all of my letters on this because that would be really boring, but I am going to do a couple of movements, and then I'll put a second video in there for moving through curves. But it's really nothing crazy about how to move through the parts now. Now it's just a matter of what line are you on, N06, okay? And what do you want to move to? So I moved to point B now. So I was at point A, I plunged into the part, I moved to point B, and so at this point, I have milled this part right here, okay? It's milled from point A to point B. I'm up here now. Now I've got to go in a straight line to down here, okay? So I'm going to go from point B to point C. And so I look at my point C reference guide, okay? Look at point C. And point C was 0.9375, 0.3125. Okay, so that is 0.9375 and then 0.3125. And so now I've gone from A to B, B to C, and you don't want to move up through the part to point E because you'll start milling an edge of it. And even if this was straight in the middle of this, you wouldn't want to move there anyway, because you don't want to move through a part that you've already milled unless you're milling new things. So what you need to do is actually pull the bit up above the part. So we're going to pull the part, we're going to pull it out of the part, and that's going to be line 7. And we're going to move on our Z-axis to Z.1. And this is going to be my notes for this guy. Actually, let me write out 2.7. C. And then my notes for this one are to above the part. Okay, so now I'm not milling anymore. So we're not milling anymore. We're above the part. And so now we're actually ready to move to our next point. So line 8. Line 8 is going to be, well, I was at point C. I need to go to point D. So I'm just going to put in point D here. I'm going to look at my reference chart at point 5000 and then point 9375. So point 5000 and then point 9375. And then I'm ready to go put my notes in here to point D. And then you don't want to move in two directions at the same time. I would not want to put my z-axis here because you would get a curve and it would mill in eventually towards the end of it, and it wouldn't give you the right thing. You don't want to move on all three axes at the same time in just in this intro. Okay. So I'm going to write another line, NO9. And this one is just going to be Z negative 0.0625. Okay, and my feed rate is going to be 9. Okay, so sorry, one last thing. I can move in a rapid movement here, GOO, because I'm above the part. Okay, so GOO above the part, and then I'm going to go back to GO1 here, and I'm going to go slowly, feed rate to plunge back into part. Okay, so we're going to say plunge 1/16. And yes, you do need to write out the notes. You cannot, I don't want you to or the comments. I do not want you to skip the comments, because when you have errors, because you will have errors, the comments are going to help you out with what you're supposed to be, what the part is actually supposed to be doing. Okay, or what the machine is actually supposed to be doing. Okay. Up next, man, I'm at 12 minutes. I gotta get to the curve, and then I'm gonna end the video. I do want to show you guys how to do the curve part of it, and then I'm gonna end the video because it is getting a little bit lengthy here. So N10, okay. So not my line 10 code. I'm looking at G01, and I'm at point D right now. So I've got to go to point E. And point E, I'm going to look at my reference guide here, is 0.7500 and then 0.9375. 0.7500 and then 0.9375. Okay, so I've now moved to point E, to point E. And then I'm going to go to my next line, which I actually need to pull back out of the part. Okay, so if I look at this, I've milled here, I've plunged in at A, gone to B, gone to C, I've pulled the mill back out, and I've gone over to D, I've plunged back in, I've gone to E, and now I've actually got to pull the part out, pull the mill out before it goes to F. Okay, so I'm going to say Z 0.1, and we're going to say feed rate 9, and this is above the part. Okay, and then we're going to say line 11. We want to move rapidly, okay, rapidly to point F, and I'm going to do 2 more points. I'm going to go after F. I'm going to go from F to G and then show you how to do the curve on H. Okay, so I don't want to spend too much time anymore on this because it's really kind of repetitive after this point. Okay, so I have GOO, and I'm going to go above the part at point F, and I'm looking at my reference guide right now, and point F is 1.1875. Your point F is probably going to be different because you probably don't have the same initials that I have. Okay, and so it's going to move there, and we don't have to put the feed rate in on this case because it is moving quickly, and we're going to say 2 point F. All right, and then I'm on my next page. Okay, So I'm currently at point F above the part, which means I need to move into the part. And sorry, what was my last line? So I've got N10, and my G code is going to be G01. Make sure I'm moving at the right speed. And my X value is not changing, my Y value is not changing, but my Z is. I'm going to plunge into the part, and that plunge, let's look at what we had before, just want to make sure we're all consistent, was negative 0.0625. Again, a negative on the Z means you're in absolute programming, means that you're going into the part, okay? So we are plunging at 1/16 of an inch at 9 IPM, okay? And that's our feed rate is going to be F9. Okay, so now that we're in the part, we're going to go 2 more lines. We're not going to go past that because I just want to get to a curve and show you the curve, and then I'll post another video on actually how to type this into your code, into the software. So I have N11, and we're looking at G01. Okay, so straight line. And let's look at what we were at last time. We were at point F, and so now we're going to go to point G. Again, I'm going to look at my reference guide, and X is going to be 1.1875, and then it's going to be 1.6875. If you're wondering where I'm getting these 2 numbers, I'm getting them from here. I made this from this. Okay, so I had to design it first, and then I had to identify all the points on it. So again, we're at point, let's see, we were at what, point F, and now we're at point G, to point G, and we are milling at a feed rate of 18 inches per minute. And this is pretty slow, but we want to be conservative. We don't want to break anything, especially since this is our first time doing stuff. And now we are actually ready for the curve. Okay, so at this point, we've milled all of A, we've gone from F to G, and now we're ready to go from G to H around a curve. And so when you're going around a curve, you've got to think about what direction you're using, and then which code you're going to use. So for curves, we're going to use this one, G02 and G03, depending on which way we're rotating. And so it comes down to our planning tool here. We went from F to G, and now we're going to go from G to H. Okay, so that means we're rotating in a clockwise direction. So we're going to use G02. Okay, so we have line 12, and we're at G02. Okay, so that tells us that we are going through a curve, and the curve we want to end at is point H. So we're still going to put a point H here, which is 1.50. And then we have 1.375. Okay. But when we have a curve, we need to tell the machine to go in a certain radius. So we're going to go to radius here, and we're going to figure out what our radius is. So we have 5 squares here, right? Remember I was telling you in the last video that you got to figure out what make sure you match up your radius. So we have 1, 2, 3, 4, 5. Now, you could figure out what exact spacing is for all of them, right? All the spacing, and then say, well, each space is worth this much, and then I'm going to multiply that by 5. Or you could do kind of the cheater way. It's already done for you down here. You just count out 5 spaces. So we go 1, 2, 3, 4, 5. And so our radius is 0.3125. And so we're going to put that in here under radius 0.3125. So R3125. And so we're going to say 2 point, what did we say, GH? And we're going to say clockwise curve, radius 0.3125. Okay, and so that gets you all the way to here, right? So I'm actually programmed half of this. I don't want to make you sit through the rest of the program. These curves are all the same that we did. Everything that I've programmed here is clockwise. If you wanted to, let's say if you wanted to go start from J and then go up to I and then move back this direction, you could, but this would be the counterclockwise, because clockwise, remember, it's going the same way as a clock. That's this way. So clockwise, counterclockwise, it's just the other way. Okay. So I'm going to end it here because it's already 20 minutes long. I don't want to take up any more of your time on this because eventually you have to do it. So now is your time to go do it. This is how I did the A and the M and the G. I'm going to finish writing my program, and then in the next video I'm going to show you how to get it into the into our software. I'm only going to do one of those videos because it will be the same for the absolute and relative programming either way. So no matter what type of programming you're using. So look for that next one coming up. Thank you.